start. Very good morning to all. I am Dr. Brahmaiah, Professor of Electrical and Electronics Engineering, St. Peter's Engineering College, Hyderabad. Electromagnetic field theory. Electromagnetic field theory is a subject which deals with electrical field, magnetic field, and electromagnetic fields and phenomena. Complete understanding the behavior of materials, components and equipment used in electrical and electronics engineering, that is inductors, capacitors, electrical motors, generators, electrical heating, transmission lines, lighting, power electronics, medical electronics, biomedical systems, telephone, radio, television, wireless communications, satellite communications, mobile communications, microwave communications, weather forecast radars, remote sensing radars, etc. require a knowledge of electromagnetic field. Understanding of electromagnetic field is understanding of electrical and electronics engineering. Electromagnetic field is more accurate than circuit theory. First, I will discuss a brief and necessary mathematics that is needed for the entire course. Here I will discuss about scalars and vectors, unit vector, dot product and cross product. First I will take fundamentals of scalars and vectors. First scalar. Scalar has only magnitude, no direction. Scalar has only magnitude. And it has no direction. Example is mass, temperature, charge. Vector. Vector has both magnitude and direction. Magnitude and direction. And the example is velocity, force, electrical field, magnetic field. Next one is unit vector. Unit vector is a vector which has a magnitude of unity and direction. A unit vector is a vector which has a magnitude of unity and direction. The unit vector for a vector is given by dividing that vector by its modulus. So unit vector A is equal to vector A divided by the modulus of the vector. Is the unit vector for the vector A. This is vector A, this is modulus of the vector. The concept of unit vector is useful in representing the vector in terms of its component vectors. A is the vector. We are representing this vector in terms of its component vectors. Ax is one component, Ay is another component, Az is another component. Ax is the component of vector A along x-axis. Small ax is the unit vector along x-axis. Ay is the component of A vector along y-axis. Ay is the unit vector along y-axis. Az is the component of A vector along z-axis. Az is the unit vector along z-axis. The modulus value of vector A or the absolute value of vector A or absolute value of vector A is equal to square root of its components. Ax square component, Ay square plus Az square. Next one is dot product. Dot product of two vectors A and B is given by AB cos theta. The dot product of two vectors A and B is given by A dot B is equal to AB cos theta, where theta is the angle, smaller angle between vectors A and B, where theta is the smaller angle between vectors A and B. Now we will take two vectors and we will find out the dot product of the two vectors. A is given by vector A is given by Ax is the component A small ax plus Ay plus Az and vector B is given by component vectors Bx Ax plus By Ay plus Bz Az. This is the A vector represented by its component vectors. Is the B vector represented by its component vectors. Bx is the component of B vector along x-axis. Ax is the unit vector along x-axis. By is the component of B vector along y-axis. Ay is the unit vector along y-axis. Bz is the component of B vector along z-axis. Az is the unit vector along z-axis. Now we will find out dot product of these two vectors. A dot B is equal to Ax small ax plus Ay into unit vector Ay plus Az into unit vector Az dot B vector Bx plus By Ay plus Bz into Az is equal to, we are multiplying this term into this one, this term into this term, this term into this term. Ax Bx into Ax dot Ax plus Ax By into Ax dot Ay plus Ax Bz into Ax dot Az plus this second term in the first vector into this term into this term, this term into Ay Bx into Ay dot Ax plus Ay By Ay dot Ay plus Ay Bz into Ay dot Az. Now this into this, again this one, this one. Az Bx into Az dot Ax plus Az By into Az dot Ay plus Az Bz into Az dot Az. Ax, x is the same vectors. The angle between same vectors is 0. So cos 0 is 1. This is two vectors adjacent to each other. So the angle between any two adjacent vectors is 90 degrees. Cos 90, 0. So Ax dot Ax is equal to Ay dot Ay is equal to Az dot Az is equal to 1. And the remaining terms Ax dot ay is equal to ax dot az, this one is equal to ay dot ax, ay dot az is equal to az dot ax is equal to az dot ay is equal to 0. Substituting these values in the above equation, we will get a dot b is equal to ax bx plus ay by plus az bz is the value of a dot b. And dot product obeys commutative law because it has no direction. So a dot b is equal to b dot a. Next one is cross product. Cross product of two vectors A and B is given by AB sin theta AM. Cross product of two vectors A and B is given by A cross B is equal to AB sin theta into AN, where theta is the smaller angle between the vectors A and B. Theta is the smaller angle between vectors A and B. A is the unit vector, AN is the unit vector, normal to the plane, containing the vectors A and B. Plane containing the vectors A and B. The direction is given. It is in the direction of advancement of right-handed screw when A is turned into B. So cross product is involved with magnitude and direction. So it is not obeying commutative law. So A cross B is equal to minus B cross A. Now we will take two vectors and we will find out the cross product of that two vectors. A is given, we will take the same vectors. A is equal to AX, small ax unit vector plus AY plus AZ is the components of vector A along x-axis, y-axis and z-axis. AX, AY, AZ are the unit vectors. along x-axis, along y-axis, along z-axis. And B vector is Bx, plus By, plus Bz, Bx is the component of vector B along x-axis. By is the component of vector B along y-axis. Bz is the component of vector B along z-axis. Ax is the unit vector along x-axis. Ay is the unit vector along y-axis. Az is the unit vector along z-axis. A cross B. A cross B is equal to Ax into unit vector Ax plus Ay plus Az cross Bx Ax plus By plus Bz Az. Take the multiplication. Is the first term in the first vector. This term into this term, this one into this one, and this term into this term. Ax Bx Ax cross Ax plus Ax By into Ax cross Ay plus Ax Bz into Ax cross Az. Second term plus Ay into Bx Ay cross Ax plus Ay By into Ay cross Ay plus Ay Bz into Ay cross Az. Now we are taking this term into this term into this term into this one. Az Bx Az cross Ax plus Az By into Az cross Ay plus Az Bz into Az cross Az. The angle between the same vectors is 0. Sin 0 is 0. So Ax cross Ax is equal to same vectors Ay cross Ay is equal to Az cross Az is equal to 0. So remaining terms A cross B is equal to, we are following right-handed screw. This is X, this is Y, this is Z. When X is rotated towards Y, you are getting Z. When Y is rotated towards Z, you are getting X. When Z is rotated towards X, you are getting Y. So this is AX BY, AX BY. X is rotated towards Y, so it is in the positive direction. So we are getting AZ. Next, AX BZ, AX BZ. X is rotated towards Z. It is in opposite direction. So minus AY. Minus AY. Next, AY BX. Y is rotated towards X. Y is rotated towards X. It is in the negative direction. So minus Z divided minus AZ. Next, this is 0 plus AY BZ. Y is rotated towards Z. It is in the positive direction. So you are getting AX. Plus AZ BX. Z is rotated towards X. Z is rotated towards X. It is in the positive direction. So it is AY. Next, AZ BY, EZ BY. Z is rotated towards Y. It is in the negative direction. So you are getting minus AX. Minus AX. Now simplify this one. So A cross B is equal to AX BY, AX BY AZ minus AX BZ AY minus AY BX AZ. Next, AY BZ AX. Next one is AZ BX into AY minus AZ BY AX. Take the common of AX, AY and AZ. So A cross B is equal to A cross B is equal to AX are taken common. So this is AY BZ minus AZ by into ax plus y times plus az bx minus ax bz into ay z terms here we got plus ax by minus ay bx into az. This is the final answer of A cross B. This can be conveniently expressed into a determinant. A cross B is equal to unit vectors ax, ay, az, and the components of A vector ax, ay, az, and the components of B vector bx, by, bz. So you will get the same result.